All right.
Okay, so welcome everybody for our first seminar this term. And I'm super pleased to introduce Christopher Davis to you. He has been working as an engineer, manager, author, and consultant since the late 20th century. He's dating himself here. And for the past 4 years, Chris has been focused on implementing innovation in retail with major customers at Microsoft. Before coming to Microsoft, Chris led various innovation efforts at Nike, including the Fuel Band, Nike Plus mobile and web apps, and their development teams moved to DevOps and the use of cloud computing. And he wrote a book on agile metrics in action. Before that, Chris was the CTO for a major consulting company in the DC area, and early in his career, engineered and developed several cutting-edge software-based systems. And on top of all of this, he's also currently working on his PhD in technology management at PSU, and studying the state-of-the-art working models for human AI collaboration. And when he doesn't do that, he enjoys playing classical guitar. He's a trained classical musician and building robots with his kids. So I'm super, super pleased that Chris is making time for us after a full day of staring at screens at work. And he'll talk about making AI real for every developer and every organization. Thanks, Chris. Welcome.
Yeah, thanks, Antonia. And I'm really happy to be here, excited. This may be a little bit of preaching to the choir, but I can tell all of you that through my journey in my career, I've been through a lot. The ETM program at PSU has been great. It's been transformational for my career. I've got my green sweater on today. I've got my Portland State notebook. So, for all of you that are in the ETM program, you're in great hands. And so I'm really excited to be here today and be speaking. And I know this is kind of I'm happy to present, and I can talk about this stuff all day. But if anyone has any questions or any thoughts, I mean, you can always feel free to jump in. It doesn't bother me if you ask questions or interrupt me. I'm happy to field them as we go. And so I'll be talking about, I guess, a few things today, thinking about artificial intelligence. I guess if there's a lot of hype around AI today. So, firstly, why? What is all this hype about? And then really, I want to talk about the tools that are out there to help accelerate the adoption around artificial intelligence. There's a lot out there to get started, and you don't need a PhD. See, I haven't finished my PhD yet, and I do this all the time. So you don't need a PhD. And also, talking about just some common patterns in use and bringing up a few examples as well. And having said all that, you saw Microsoft on the slide. I work for Microsoft. That's my day job. Microsoft pays my bills, or they pay me and I pay my bills. But having said that, in all fairness, this presentation is very kind of Microsoft-y because that's where all my professional background is. Having said that, though, trying to be as non-biased as possible, really I'm going to be looking at tools that are common across really the three biggest cloud platforms out there today. And so, I, of course, working for Microsoft, that's what I talk about and work with all the time. But then I'm also familiar with a lot of Amazon Web Services. I mean, at Nike, we used a lot of that when I was there. And the Google platform, and from a competitive perspective, I see them out in the field a lot. I'm familiar with their tools to an extent. So everything that I'm talking about is going to probably have Microsoft branding on it. That said, if for some reason you absolutely love AWS, or you work for a company that uses a different cloud platform, or you're adopting it for some other reason, that's totally fine. I'm not here to sell you on Microsoft. I'm just here to give you kind of use cases and examples to show you what's out there today. And I'll try to make sure that as I talk about this, I can go back and mention these are the other cloud platforms as well, and that they have these similar tools, and you can do a lot of the same stuff. So just wanted to kind of put that out there as so you don't look at this and think that I'm totally biased right off the bat. So, which maybe I am a little bit, but I'll try to be as non-biased as possible. Firstly, really around artificial intelligence today, so many people have talked about it. There's economic reports saying how it's going to completely disrupt the workforce. that workers are going to completely change, or there's going to be mass unemployment, all kinds of crazy things. Lots of people are talking about it. Companies are trying to adopt it. There's a ton of hype about it. And then on the other side of that hype, you have a lot of companies that are investing a lot into artificial intelligence or machine learning, and then maybe not getting a lot out of it. And so really bringing up just these kind of few examples up front and looking at some real use cases where they've made a difference. Not from here, after kind of just talking through a few of these, I'll start diving into the tools that you can use to adopt today, regardless of your skill set. First off, the CDC, I think, being pretty appropriate, especially with living in a COVID world, the whole idea around conversational, conversational interfaces. Chatbots have exploded. They've just taken over between Amazon Alexa, Cortana, Google Home. All of these different platforms kind of really allow you to, as a developer, to have these chat-based interfaces. All of those interfaces are all based on artificial intelligence. They're all based on natural language. And there's only so far they can go. I would say kind of from a development perspective, they're a bit early days. They can't, in most cases, carry on a really meaningful conversation like you and I could. However, they are really good at simulating any kind of conversational interface. They're great for different ways to interact today. If you are talking to your Alexa or you're talking to your phone or your mobile, the whole idea of this being able to have a conversation with an interface rather than pointing and clicking just feels a lot more natural. And also it comes kind of from the roots of artificial intelligence in the first place, that whole idea of being human, acting human. And so we see more and more of these chatbots come to fruition. The CDC launched a chatbot really to help people self-assess around COVID-19. And it just asked people a bunch of questions, took all that data, crunched it, and then was able to give them a recommendation. That's just an example of one organization that was able to make good use of artificial intelligence. That's one strong use case today, is natural language processing and conversational interfaces. You're kind of going through a few more of these. If you look at Carhartt, what they've been able to do is, you see the big headline, 200% increase in sales. How did they do that? What's interesting about the way they used artificial intelligence, and each of these use cases kind of showcases a little bit of a different strategy. They were trying to figure out where can they put their retail locations to get the most sales. Like, where's the most effective place to really put a new retail location to best serve their customers? So taking all of this econometric data, population data, all of this data from all over the place, including data from their customers that they knew about, they were able to determine, I think it was 3 or 4 new locations of stores to implement. And in doing that, those new stores, because they had all of this kind of intelligence behind the process of selecting a location, were by far their most profitable locations, like twice as profitable as all their other locations combined. So being able to use really this machine learning technique to be able to suck in all of this data and be able to figure out where to put these stores for the best kind of propensity was hugely helpful for them. So using this methodology, that's something that they're starting to move forward with. Looking at Schneider Electric and being able to improve their operational efficiency. You see this with lots of other companies as well when they're looking at collecting data with how their operations are moving. Taking all that data in, we live in a very data-rich world where there's essentially data all over the place. A lot of it is public. A lot of these companies are trying to use the data that's kind of specific to them to get the most efficiencies out of what they're doing. And Schneider Electric was able to get a large, pretty significant improvement in operational efficiency. And that's not, using artificial intelligence's supply chains has become a core use case, especially in the retail world. Being able to find, how to do things more effectively, firstly, and then secondly, being able to automate those processes. And when you think about automating processes, you're thinking of, you can start thinking of what are all of these very kind of human things that you can do with artificial intelligence that you couldn't automate before. I mean, natural language is a good example. Going back to that, also any kind of image analysis, which used to be a very human thing to do, machines can do actually more efficiently than people can today. And we'll look at that too in some of these tools that we're going to look at. And that's all I'm going to touch on this slide. I could go into some more of these later, but if we want to talk about it, we can. I just want to keep moving. You know, when we're looking at, and this is kind of a Microsoft-y point of view, but I think pretty much every major cloud provider, every platform is going to say the same thing. You know, we try to break this down into business problems, business outcomes, to really be able to say, okay, well, artificial intelligence is cool. It can do a lot of cool things. And what are you trying to get out of it? Like, what's the real key high-level thing to start at? And then you drill down from there to figure out which technique is going to be best for you and how you can get the most efficiencies. I mean, from my day-to-day perspective, we kind of have these 4 different pillars that we look at. You know, the first is all around B2C interactions, and that's engaging customers. So how are you using artificial intelligence to be able to engage customers at scale? I mean, Amazon is amazing at this. Amazon is Amazon because they are so good at it. Their recommendation engines, all of the suggestions that come into play, all of the data that they have, being able to use that in a way to make sure that people are really engaged with their platforms and using their tools. This is extremely common in retail today. Operations, I touched on a little bit. You know, operations is another really key core use case. If you think about all of the different parts in a supply chain, for example, that could be automated, it could be tied together with different types of machine learning, artificial intelligence, anything that has a lot of data behind it, you can probably use some type of technique to really optimize that and get the most out of it from a machine learning, artificial intelligence perspective. Transforming products is another interesting one, and I'll talk a bit more about that. But if you look at really anyone that's integrating artificial intelligence into their consumer-facing products, it's a little bit different than engaging consumers. But again, you know, Alexa is a great example. Alexa is an artificial intelligence, and it's a product. You can buy it, and Amazon makes money off of it. But think about the natural language that you're going to put into different products. I mean, cars is a perfect example. We're moving closer to self-driving cars, but I know that you will all deny it, but I'm sure you've all looked at your phone in your car at some point, even though it's illegal. I won't tell anybody. It's okay. I do it too. No, but I won't admit it in public, even though it's being recorded. All right. Well, that's okay. So, but thinking about how you can really use these interfaces to connect with your consumers better. And so conversational interfaces, again, it's a great way to integrate that into a mobile platform where you can't use your hands. So Alexa is really popular for people that are cooking. People have them in the kitchen because if your hands are all sticky and full of gunk, you don't want to be scrolling through and touching your nice, expensive monitor screen. And any kind of customization at scale, anything like that. And then, from a B2B perspective, we always like to think, how are you using this to empower the employees in your workforce? And a part of that is that when you look at especially the demographics that are coming up today, yes, I dated myself in my bio. I've been doing this for quite some time. But, especially, I mean, I have 2 kids that are pretty young. They're on their computers all day. I think everyone who has kids now, they're over the last year, especially when school transitioned from home, they're digitally native. You can even go back and say millennials are digitally native. I'm from Generation X, and I would say I'm digitally native. I had a computer when I was a kid, and I learned how to use it. And then, when phones came out, I definitely wanted to adopt those. So all of these people that are being engaged from a consumer perspective come to work, and they expect that same digital experience. The last thing you'd want is to have a bunch of paperwork to fill out when everything in your daily life is digital. It makes absolutely no sense. So being able to bring that artificial intelligence to improve the workforce, improve the work experience, especially in an economy where work is, it's really competitive to find high-skilled workers, is a really key use case to think about. And when you're looking at how to bring these use cases to life, and again, so these are Microsoft terminology kind of things, but all of the major cloud providers have very similar, if not the same offerings, just named something different. And if you look at kind of those three things that we have up there: on your terms, mission critical, responsible. The reason those are there, on your terms, mission critical, being able to crunch this data, first of all, wouldn't even be possible if you don't have a massive data source somewhere. And it's really cloud technology that empowers a lot of companies to be able to get access to that data or store that data. Otherwise, buying hard drives and constantly maintaining them, it's a pain in the butt. No one wants to do it, and it's expensive. And data is extremely critical. It's been called the new oil. I think that's kind of an older term. But if you think about it now, it's absolutely true. All of that data that a company collects about its customers, about its processes, it's unique to that company. Being able to store that on a massive scale is really key to be able to get benefits out of machine learning, out of artificial intelligence. Being able to do that in a cloud that is redundant and secure is mission critical, which is why AWS, Google, Azure have data centers all over the world, massive data centers that will back stuff up constantly, usually automatically for you. And one thing to always think about, and something that's I know front of mind for a lot of researchers, is being responsible with artificial intelligence. There's a lot of stuff. I'll be talking today mostly about kind of tools to be able to unlock this type of optimization. But at the same time, there's a lot of bad stuff that goes on with AI. One of my favorite sites that I go browse in sometimes is called Papers with Code. If you haven't seen it, you should go check it out. It's super cool. It's great. It's got like the leading edge papers on artificial intelligence, and then most of them have links over to GitHub, so you can actually go implement that stuff after you read about it. It's great. But when you look in there, you're going to see a lot of stuff around adversarial AI, being able to deep fake. We probably have seen deep fakes in memes and whatever else that's out there. And even I've come across this in the real world. I had a company I worked with one time that said, hey, we work with celebrities, but bringing them into the studio and having them record all of these things that we want them to record for us is kind of cumbersome, and it's really hard. They're celebrities. They usually are super hard to get in the studio in the first place. So is there a way that we could minimize the time by maybe just using smaller clips of them and then generating their voice for certain things? And at first you think, oh, totally, we could do that. But then when you really go back and think about it, I mean, is that ethical? Is there a good business case for this? In this case, so in a company like a Microsoft, we have these ethics committees where, we literally have an AI ethics committee. And for this use case, I had to take this to the committee. They had to present it. They had to go through all of this. And these are all, leading AI researchers going through this and really asking those hard questions is, before I go through this process, am I doing something that's ethical? Do I want to support this? Or do I want to just say, no, we're not going to help. We're not going to help you. If you do it, we can't stop you, but we won't help you. So you always have to think about, from a responsibility perspective, with the power of these types of platforms, is what you're doing ethical and responsible? And then, there's these three kind of key categories here that we're going to really talk about, which is kind of like your pre-baked APIs that have AI out of the box, your machine learning capabilities to be able to build your own models with your own data. And then, actually, no, off the top of my head, it's been a long day. I'm kind of, what is my third one? Hey, I know it here. It's wait, I'm going to get there. Yeah, these are my three use cases. Yeah, let me go back a little bit, because I wanted to talk about, when we look at some of these pre-baked AI services that are there. Now, I guess if I go back one more, one of the, if you look at what Microsoft calls cognitive services, can't remember what Google calls it, but essentially you can call an API and have artificial intelligence and machine learning kind of baked by Microsoft, baked by Google, baked by Amazon behind the scenes. So you can send it a sentence and it will give you data back great example is, I mean, simple natural language processing today, if you take keywords out of a document, if you want to look at named entity recognitions, celebrity recognition, things of that nature, even summarization to a point, you can do all of that with these out-of-the-box AIs without having to go through and train all this data yourself. Before these APIs were available, you would have to go out and find a very large corpus and train it. For example, Wikipedia. But even if you train these models on Wikipedia, that's something that takes like 5 days. I mean, for these algorithms to run, unless you have enough compute power to run this whole thing. So you have a lot of these APIs popping up, and we'll take a look at those and kind of the use cases around them and why they even exist. And if you think about how Microsoft or Amazon or Google can even come up with enough data to train these pre-baked machine learning AIs. I mean, from a Microsoft standpoint, look at the data that Microsoft has at its fingertips. Let's see, 1.8 million hours of meetings that we're able to transcribe in real time. And how can we do that? All of these algorithms come back to looking at data, distilling information from data, looking at patterns in data. So the more data you have, the more apt you're going to be to create better algorithms. And there's nuances to that to an extent. I don't want to get too much into the details of that so much, but think about all of that data that goes through Microsoft Teams. Think about all of the data that goes through Microsoft Office. For pretty much everybody uses Microsoft Office in some way, Word, Excel, Outlook, email, something. All of that data, all of that text data, all of those spreadsheets that is available for training. That's why open up these apps and it says, hey, can we use your data? Yeah, well, this is what it's getting used for training these types of algorithms. And then with Microsoft, when you see Microsoft make an acquisition like Xbox or GitHub, part of that is their larger strategy around what kind of data do we want to get smarter as a company. If you look at all the data in LinkedIn, I mean, pretty much Microsoft knows everything about job trends, how people market themselves, how companies market themselves over LinkedIn. If you look at Xbox, how people play games, how they communicate over those games. And you look at Amazon, they have tons of e-commerce data. And I think when they bought Whole Foods, there was a lot of speculation around, well, are they trying to get into brick and mortar or are they doing this for the data? And the same thing with Google. I mean, everyone, have you Googled today? Probably, I'm sure everyone on this call has used Google at some point today. All of that data they're using to get smarter with all of their APIs to figure out, how can they pre-bake these things for people to use. Now, even though it says, built on breakthrough AI research, really everyone's using the same algorithms in the back, I think, pretty much. And then some companies are open sourcing what they're doing. And so, being able to kind of harness all of this research and R&D that kind of these larger companies that have tons of data are making available, you really see these kind of 3 major categories around how companies are starting to use artificial intelligence and how they're able to get the most value out of it. When you look at AI-powered apps, if you think about, the BBC uses it for recommendation engines, Spotify, same thing, recommending music. Adobe extensively uses AI across all of their products to get smarter, UPS for figuring out how to get deliveries faster. And with APIs, it's pretty straightforward to bake artificial intelligence into apps today. I mean, local Nike uses it for their Nike Plus running app, and several of their other apps to surface recommendations. But a lot of that is around what are your customers doing, finding like people and saying, hey, well, you will probably like this, or something like that. If you look at the whole concept of knowledge mining, this is super interesting to me. I think a lot of the research I'm doing falls into this category. So I love talking about knowledge mining. But if you look at what this is, and we'll look at some of these patterns later, it's really that ability to distill some type of knowledge from large bodies of data. And I'll dive deeper into some of these examples. Actually, looking at the Atlantic, what's really interesting about them is what they are using knowledge mining for is they've been a reporting newspaper for a very, very long time. So they've only had digital records for a percentage of their history. Actually, a lot of the data they have is paper-based. And so, being able to kind of search through and catalog all of that is totally impossible. I mean, it's impossible if it's all on paper. So being able to scan that and using OCR, character recognition, to be able to take a PDF and extract that into text, and then be able to use out-of-the-box artificial intelligence like sentiment analysis and other types of metadata, being able to add more metadata to your to your documents through basically, AI-based pipelines, you can really find a lot of really rich data on stuff that was just extremely hard. And again, it goes back to, you would have had to ask a human to do this a long time ago. Here, read through these things and write up tags and figure it all out. Now, in this process of knowledge mining, you're able to take a lot of these out of the box, off the shelf APIs and enrich these documents with metadata to usually make them a lot easier to search. Kind of at the end of the day, that's what a lot of companies do with it, to make it just more accessible, but then also to find insights. And then finally, machine learning. And I think a lot of people mix up machine learning and AI here. I use them interchangeably a lot, but I think you can really find that the delineation is that artificial intelligence is that pre-baked model that's doing something that, it's really hard for machines to do with procedural type code. Machine learning is really, it's a technique to be able to distill these patterns from data and build models that are then used for AI. But it's lumped into the whole AI ecosystem because it's really a precursor to it. And there's a lot of, I've seen people call machine learning, development 2.0. It used to be you'd write all this code, procedural code, if, then, when, blah, 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 blah. But now you have these pre-baked algorithms, neural networks, and many different types of algorithms. And you can kind of clean up your data, throw it at the algorithm, and then get back a model based on what you're trying to do. And there's all kinds of interesting stuff. I'll talk a little bit more about that later. So, looking at these three use cases and diving into these a little bit and kind of those tools that you would use to do it. And again, this is Microsoft-y, but there are bot services to be able to build your own bots for pretty much even IBM has them. And, I don't even, honestly, sorry, they're not really one of the big cloud providers anymore, I think. And then the other one, Microsoft calls cognitive services. Essentially what cognitive services are is they're APIs that just pre-bake all of this artificial intelligence capability into them. So they become much easier to adopt. If you're a developer, I know I've worked with a bunch of I've been a developer for a long time. Calling APIs today, like every developer has to do it. It's a core skill set. If you're a developer that's used to doing web development or something like that, and then you're tasked with learning how to do machine learning, yeah, that's a jump. That's a lot harder. And if you're a business owner and you're really thinking about how do I access these tools, and you go to your development team, your VP of whoever, and say, hey, I want to do some machine learning, some artificial intelligence, and they say, yeah, okay, sure. Well, we need a year to train our people, or I'm going to go do research for a few months or something like that. When I was a manager, developers would tell me, I'm going to go do research. And I'd be like, I don't want you to do research. That means nothing's getting done. So sorry for all you researchers on the call. That was just my opinion in the business world. But, being able to meet them on their terms and be able to call the APIs to integrate this into apps is enables you to integrate this capability much, much, much faster. And again, this is across pretty much every cloud has these same things. And I can tell you that 100% for sure, because I've been in RFP processes where I've had to do bake-offs and compare all of these different ones together. And so, going through the kind of different APIs that are possible today, and again, you look at the data that's available, and that's where these categories come from. So if you look at, the ability for apps to make better decisions, personalization, being able to provide relevant recommendations, or being able to personalize an experience based on how users interact with it, or how people like those users interact with it. Anyone that can collect lots of data about how their users are using stuff can create a personalization engine. So if you look at some, obviously Amazon has a platform where everyone uses it. Google has a platform that everybody uses. Microsoft has Bing, multiple other websites, lots of different interactions, enough where we can create these personalized, personalizers out of the box. Another good example is form recognition, or if you think about, I guess that is technically under the Vision API. If you think about the ability to look at a form, and that's something where there's lots of forms out there, it's actually really kind of hard to read just a standard, if you have a form format, how do you turn that into Excel, or how do you move that data around? And the ability to take any kind of forms, a good example is like a receipt. If you have to do receipt scanning or look at that data for some reason, that's something that's a very manual human task to do. But now you can scan all that and have your artificial intelligence pull all that data out, tag it, put it in the database, and now it's readily searchable, archivable, whatever you want to do with it. And so that ability to do any kind of form recognition is another kind of key element that you're going to see. Anything around speech to text and text to speech. And right, speech is different than language, which may sound weird, but then again, think about all of the people using cell phones, all of the people in meetings. Right now, all of our voices are going through, well, my voice is going through Zoom right now. I don't know what Zoom does with their data. They obviously they don't have the same type of AI APIs that some of these others have. But there's a lot of data out there to be able to train these algorithms on. So be able to do, understand what people are saying, or be able to take text and then articulate it back in a normal way that doesn't sound like a robot. I mean, that's the easy part. But having the inflection and all of the other things that make it sound natural are what artificial intelligence is going to let you do. And those are, some of the APIs available there. Around language, you have a few different things. You have text. No, wait. Oh, no. Yeah, actually, I'll get to the next slide. But any kind of text analytics, and I mentioned this already, like keyword extraction or named entity extraction or any kind of summarization, or sentiment analysis is a really big one. Being able to pull those things out of either sentences or, it's harder with larger text. Usually it's small text that you'll see on these APIs. Especially Twitter feed analysis is kind of a classic example at this point. Those are pretty straightforward and out of the box. And if you kind of break these down into all the different APIs available, again, okay, I forgot to take Azure off this slide, but again, all of your major cloud providers are going to be able to do this. Vision, any kind of, I think form recognition was the example I used earlier, but facial recognition is extremely common. There's a lot of research around how do you now recognize people with masks on as well. It's just they're, so it's a little bit smaller data, but being able to do facial recognition, and you see that all the time with your phone. You log on with your phone or computer with my face. My kids now will shove my phone in front of my face if they need to log on for something. But being able to recognize forms and also ink recognition. So that would be any kind of handwritten ink, OCR type stuff. And when you put all this stuff together, then you can create these really cool, rich experiences. I know Antonia and I had talked a while back around, how do you have automatic transcription from your meetings? That's something that Zoom and Teams can both do now by doing image analysis, by doing speech recognition, kind of putting that all together. And then you have kind of in AI this concept of training like a base model with a lot of data, and then taking a little bit of data and training it so you can hone it down and make it really specific. So when you see APIs like the custom vision API, that's a good example of if you take all of this kind of pre-trained API data, and then you want to be able to, wherever determine the difference between, or, kind of what people are wearing, some kind of fashion thing, I don't know, difference between a cat and a dog, whatever your custom vision application is, you can then take a relatively small amount of data, I think like 20 images, which is not a lot, and be able to have kind of this rich image recognition without having to learn, OpenCV and TensorFlow and all kinds of other crazy things to figure out how this stuff works. A lot of it is kind of in the back end. You just upload your images and you tag them, and then the machine learning takes over the rest and gives you a nice API. The same with speech. Translation is another use case that we see all over the place. My brother is actually a translator in Korea. That's what he does. And I remember a couple of years ago telling him, hey, man, I always tell my brother, you should learn how to program, you should get into tech. And he's like, computers will never be able to translate as good as humans, never. So guess what his company is doing now? They're pivoting to this model where they're doing more machine-based translation. And actually, a lot of his coworkers got laid off. So he's still got his job, which is good. And his wife is an amazing cook, and cooks are always in high demand, no matter what's going on with the economy. So they'll be okay. But it's definitely something that's becoming more and more advanced. More languages are starting to fit into this ecosystem. And then you start to get kind of these, again, kind of putting all these building blocks together. If you think about what you can do with speech, what you can do with text, what you can do with vision, that's when you start to get into not only like video transcriptions, language understanding, which is used for those conversational type interfaces, but then your kind of richer type of personalization, your content moderation, being able to really see like, hey, is this a good post or a bad post? Anomaly detection is kind of a classic machine learning program, essentially, right? This is gonna, again, something very, you used to have humans that would stare at lines, and when something went crazy, they'd, hit the panic button. Now all of that stuff can be detected automatically, fairly simply. But because it's trained on all of this data that these giant cloud providers already have, they've kind of provided this foundation, and now people can just upload any kind of customized, tweaky things that they want to bring it to the next level and really customize it. Okay, I'm gonna speed up a little bit here. So your bot service is just another example of, taking that conversational interface and just making it very developer friendly and easy to develop. I think there are multiple companies that have this now. It's not even the big three. Bots, I think, are super popular and all over the place. I think the last thing I saw research around this was that most people, interact with AI in some way throughout the day, whether they know it or not, multiple times. So, thinking about, I guess a lot of interfaces today are based on search, trying to find the right document, trying to find the right information. But a lot of it isn't just based on keywords. You have to think about fuzzy searches. What if you spell something wrong? What if the words are out of order? How do you kind of get over those? And then also, how do you even tagging documents to be searched in the first place? And so when you look at kind of what AI is being applied to behind knowledge mining and search, essentially knowledge mining, again, it takes all of those building blocks: speech, text analysis, video analysis, audio, image analysis. And it's able to look across all of, using those AI building blocks, can look across a varied set of documents to automatically tag them and make them more searchable. So in the knowledge mining kind of use case, you see a lot of search at the end of it. I mean, because you're not going to just put metadata on all of this stuff for no reason. You need to be able to search it and find it. This is another interesting business example. This is a shipbuilding company. I always work with retailers, so I never get to work with this look like a super cool ship. I'd love to get on this thing, but well, I don't know, it looks kind of dangerous, but it would probably still be fun. This company had all kinds of ship plans. That's what they do. They have ship plans, and they go back for a very long time. They're an extremely old company, and they had all these old like hand-drawn designs from a long time ago. And using artificial intelligence, again, they were able to make sense of these old drawings, scan them, and then be able to extract text from them, add metadata to them, and all of this. So they can then have this rich search experience digitally to find anything they wanted throughout the history of their company, where before they would actually have to ask someone to go to the file cabinet and look through all of these drawings and find things. So, being able to find these efficiencies with search is really a really key use case that we see across knowledge mining. Finally, kind of the last case is thinking about machine learning. And this is a little bit harder because oftentimes you really are going to want that skill set of someone that knows Python or R, or how to build these models, or understanding all of the different models available. But having said that, again, it goes to, just like all of these APIs were built on a large foundation of data, and they're customizable with just a little bit of data. You can take advantage of all of that history and all that learning that other people have done for you. With machine learning, and of course, it's like you're automating the automation in some cases. For looking at the data science skill set, it's super hard to find. I think this is well known. And there's been this, I think it was either Gartner or Forrester coined the term the citizen data scientist. Essentially, they're analysts that are just really good at statistics, or they're used to crunching numbers, being able to kind of shift their career a little bit and move more into doing machine learning and artificial intelligence from kind of statistical analysis. Because really, at the end, these things are all based on number crunching at the end of the day. And so there are a bunch of different ways. When you look at notebooks, you're talking about that's code. That's going to be the stuff in Tim's class. You're going to be looking at either R or Python. You're going to be building algorithms. It's going to all be pure code there. But you look at kind of what's available and what's from a lot of these companies today from automated machine learning. And a lot of machine learning is optimization. There's multiple algorithms. So which algorithm do you use? Okay, good question to try. Back in the early days of data science, just a few years ago, there were people that would just try all these different algorithms over and over until they could find the most efficient one. But why? Also, if you think about, data scientists spend 80% of their time just cleaning up data. 80% of their time. So you have a really expensive, hard to find research doing like data cleaning for 4 days a week. That's crazy. So being able to automate as much of that work as possible, and being able to get the most out of your humans that you can, and letting automation do the rest, is kind of what AI is all about. And so why not apply AI to AI? So automated machine learning does a lot of that for you. It helps automatically clean up data. It helps automatically try multiple algorithms to tell you what the best one is. Just takes a lot of the pain out of machine learning. And then finally, you have these kind of graphical designers now too, where you can use to pull different data sources in. You can create, you can clean your data with these kind of just visual boxes that you're drawing on the page. You can split and test your data in different ways using these very GUI, visual-based interfaces. So really, it lowers that barrier to entry by a lot, because now you kind of just need to know, well, is this a clustering problem or is this a linear problem? And that's much, much easier to learn than every different clustering algorithm that you need to worry about, or anything like that. Trying to figure out from a category level, you can then bring those components together to build your own machine learning models. And the whole point around machine learning even is, if these out of the box AI APIs can't do what you want, or these kind of pre-built APIs that you can easily customize by just sending your own data don't do what you want. If you have something really, really specific, especially if you look at companies that have their own data, and really that's where you're going to find any of your competitive advantage, any kind of strategic advantage. I tell people this all the time, like, don't build something that doesn't have strategic importance. It doesn't make any sense. There's a zillion software as a service companies out there where you could buy anything that you want. But when you look at your data, what makes you as a company special? What makes your process differentiated? How can you connect with your customers in a way with that data without giving that to someone else? When you're coming across those kinds of questions, then you want to think about, that's where you want to think about really building your own machine learning models if you can't get something out of the box. And then you have kind of that whole administration around it as well. If you're doing machine learning, you can think about, well, if I'm going to build out these models, that's great, but where do they sit? I mean, they have to be deployed somewhere, or else how are you going to integrate them into all of your systems, or how are you going to take advantage of it? You then have to worry about the API layer on top of your machine learning layer. So that's where you have these other whole suite of tools that come in, around. So if you think from a development perspective, you'll always hear about DevOps, which is all about merging development and operations. Because if you go back, pre, I guess Gene Kim, with the Phoenix project, the whole concept of DevOps, you had developers writing code, and I lived through this. Maybe some of you have. Then they'd kind of throw their code over the wall, the operations team, and then you had this horrible blame game. The code wouldn't work. The operations team would blame the development team. The development team would blame the operations team. It's a disaster. So how do you solve the problem? Okay, just put them all together on the same team, and they're all responsible for the whole thing. There. Now you guys can't throw things. There's no wall. Can't throw it over the wall. You have to deal with it yourself. So that whole concept of DevOps has gone into machine learning as well, because if you have data scientists building code, building models, now they can't just throw that over to the development team to manage the API on top of. What if the model starts spitting out the wrong answer? What if it's recommending something that's not correct? You have the classic example of loans, being disproportionately given to people just because of the history, not because they actually deserve to get a loan. And there's a lot of discriminatory history in that process. So how do you, make sure that you're thinking about that, you're making sure these are fair throughout your entire development and deployment process? That's where a lot of these tools for ML ops come into play, thinking about how are you testing these? How are you reproducing them? How are you making sure that they're fair? How are you deploy it? And how are you tracking it over time? I think when ML first started becoming popular, people would deploy these models and then deploy a new model, deploy a new model, deploy a new model. But because the models were black boxes and no one could really ever say what changed. Like, okay, you gave me a new model, what changed? Well, I can't really point. I mean, I didn't know what was happening in the model in the first place. All I know is my, on my test set of data, my accuracy went up. But what does that mean in a production context? And so thinking about machine learning, from that broader context, you also have to think about how it fits into your operations process, how you're testing it, how you're deploying it, and all of that. So that's a picture of I can't even remember what it's called anymore because everything's moving to GitHub today. GitHub kind of does all of this stuff too. So you always have to think about, if you're building your own models too, how your life cycle goes. And that's all, I feel like that's all normal dev stuff. If you've been a developer, the concepts are all exactly the same. And then thinking too, how are you really digging into these models to make sure they're fair and they're doing what they're supposed to do? There's a lot of really interesting work around AI. If you think about, especially, if you think about where it comes from lots and lots and lots of data. But then you can look at the overall patterns and generalized data, but then there's sub patterns inside that data. I think I was just reading something about this really kind of classic use case where overall, if you look at men and women together in this study, a drug trial doesn't really have an effect. However, if you break it down and you look at men versus women, it actually has a positive effect on men and on women. But because the disparity between men and women is different, it causes enough noise where the overall model looks like it's failing. So you have to kind of dig into this. You can't just take these black boxes for what they are. You have to be able to dig in and understand a little bit more about why the model is outputting what it is outputting, be able to go into a much more granular level to understand what features are contributing to the output of the model. And that's where you'll see tools like this, where you can go into all of these different attributes of your data, understand exactly how they affect the model, dig into subclassifications of it, and be able to explain it at a much higher level. It's really easy to just throw a big black box out there and say, improve things by 5%. People are like, 5%? That's awesome. But what does that mean? 5% of what? Why? Getting into the details of it will only help you get better at it. And it helps you be more responsible ultimately because you can understand it, you can explain it, and you can control that data in a much, much finer level. And then finally, and this is something you're seeing all over the AI community, is a lot of these tools are open source, which is awesome. So no matter what you use to develop it, Python and R, those are go-to languages. Bam, you need one of those, you're good. I think a lot of stuff comes out in Python first, but R has a lot of really interesting libraries, and they're kind of, if it doesn't do something first, it's a fast follower to Python. I think what's interesting about the two is, Python to me is always more of a developer's type language. It's very developer-y. R is not that developer-y. When I learned R, it took me a little long. Like I learned Python, I'm like, whatever, Python. It's the same as all these other languages, it's less syntax. R is a little tougher to learn for someone with a development background. But it seems that analysts seem to pick up R much faster because it's less codey and it works more with the way they're used to working. So, but both of these languages have great libraries, and they're both open source and freely available to use. RStudio is great. And there's several different. Jupyter Notebooks is extremely common. I talked a little bit about that. My favorite is Visual Studio Code, of course, but it's open source. Lots of people use it. It's really awesome. And there's a rich notebook integration built into there. And then all your frameworks out there, people, TensorFlow came out of Google, Scikit-learn, Onyx is a, consortium of major companies that work together on the Facebook and Microsoft and a few others. Keras is that K in the middle. So all these frameworks are open source. So they're fairly well documented. There's tons of examples. They're pretty open. I mean, at the end of the day, you're going to end up calling your models with an API anyway. So it's you're using this to train your models, your machine learning, and then you're exposing them in a way that other applications can integrate pretty easily. So a Carhartt example I talked about already. And then really that was pretty much it. And I'm a little bit ahead of time. I just wanted to give you kind of an overview of some of the tools that were out there, why they're there, how they're used. Yeah, that's pretty much all I had. Any questions, comments, thoughts, anything? Or
Thank you so much, Chris, for your talk. So there's two questions in the chat. I might read it, and also for free, for all of you, if you want to ask, I'm gonna give you a permission for all of you if you want to unmute yourself. But let's start with this. Elizabeth, she asking, I'm curious, have been a discussion on ethic on using data generated by anyone who uses Teams or PowerPoint. And she's assuming that the user agreed to have their data used in this way, but has it been conversation at the higher level?
A conversation at the higher, okay, sorry. So oh, absolutely. No, oh, definitely. That's something, I mean, so I can only speak from a Microsoft perspective there, but I kind of touched on this a little bit, but we have an entire AI ethics committee. And I mean, it's a combination of researchers. If you look at how Microsoft is organized, we have a massive research organization, just organizations of PhDs and labs that just do research. And ultimately, the goal is to transfer that technology. Quite frankly, it doesn't always happen. And sometimes researchers just want to sit in their room and do their thing. But there are more kind of externally facing researchers that have created a committee. They call it the Ether Committee. And it's actually, they've got a webpage that's out there. And that committee, all they do is they talk about ethics. Actually, I'm trying to see if I actually maybe even have their thing open. Yeah, I do. Did I stop sharing my screen here? Actually, I'll shut this really quick. So which screen am I sharing? Okay, cool. You can see my bazillion web tabs I have open here, but you know, this whole idea, oh, sorry, this is Microsoft Confidential. All right, well, nobody run around and tell everyone I showed you this, please. But, you know, we have this, you know, basically our group of researchers who are doing their own research, but then they're also really committed to all of the ethics that go behind all of the work that we do. So yeah, you know, when you open up Teams or PowerPoint or anything, there is a box that you check that says, yes, I can use this data. No, they can use this data. So obviously, if you say no, they don't use it. If you say yes, then it's all the data is anonymized, so they can't trace it back to who did what specifically anyway. You know, it's all just used for the larger training. It gets lost in that sea of machine learning training. Hopefully that answered the question. Okay, now I'm going through the chat too. I've got it open. Any tips for junior developers wanting to get into working with AI? Books, blogs, or podcasts? Oh my gosh, there is so much material out there. It's crazy. I mean, probably because I get a subscription from work, I like going through LinkedIn Learning, but there's tons of stuff out there. Yeah, I would say if you look through GitHub, you'll find interesting notebooks. You know, for me, you know, being a developer, I just, you know, so I've been doing artificial intelligence for like 4 years. It was really when I kind of, at the end of my time at Nike, we were starting to talk about it, but I was still, you know, very kind of procedural back then, looking at large scale systems and APIs and such. So we kind of touched on it. We didn't do a ton. You know, when I moved to Microsoft, I had to learn it because that's, you know, we do so much of it. And for me, the way I learned it was, you know, I can't say I, you know, looked at any books off the top of my head that were really good. But if you kind of find something that you're interested in and really kind of just deep dive into that, I know, you know, I actually, Tim, I like to use you as an example because Tim does a lot of interesting kind of statistic analysis around sports and baseball. And so it's like, you know, well, if you love sports and you love baseball, there's tons of data out there. It's a great way to learn how to do this stuff. Go through GitHub, look for notebooks and find that stuff. If that's not your thing, if you really are interested in conversational interfaces and you want to understand kind of how these work, there's tons of great tutorials out there. You know, I would say pick a platform and then, you know, go look through their documentation and just find, you know, their tutorials and stuff, and they walk you through it. Of course, everyone wants you to use their platform, so they're very forthcoming with documentation and examples. There's lots of great stuff out there. Any tips for, and I would like to know what your view is on the difference between AI and ML. Okay, yeah, I think I touched on this a little bit, but it's really ML is first. Machine learning is you get a whole bunch of data and you use those algorithms to create a model. And then once you have a model, the whole idea of the model is that is going to automate and you have some kind of automation. Now, when you have new data coming in, so if you take like 10 years of historical data, something looking for patterns, maybe 10 years is maybe too much, but whatever. Use it as an example. Now, when you can train the system to say, okay, well, maybe you're automatically classifying something for some reason. You know, so when new data comes in, you can say, well, based on everything I've learned from this previous data, I'm going to stick this in this queue or send it that direction or do something like that. And it's kind of those outputs from those models that are things that kind of traditional programming has just, you know, struggled with. It's much, much harder to do. And so that's why machine learning is so popular, but it's those outputs then that become your artificial intelligence. So really you can kind of look at that as the difference. If you're building artificial intelligence from scratch, okay, you're doing machine learning. It's the output of that, whatever you create, and when you apply it, that's when it becomes artificial intelligence.
Also, yeah. Chris, there's a question from Rennie Black before this question. She's
was
about, like, Chris spoke about AI chat bots right before, like, the tips about the AI and machine.
That might be just to you.
Oh yeah, I don't see it.
Yeah, because I don't see it either.
Okay, I can read it. So she said, like, Chris spoke about AI and chatbots increasing sales But how many like how many like sales are lost because of the chatbots with no live or no chat option? So
That's a great. So I love that question on a few different levels. One is because that's a great point. And if you look at anyone who's called into a call system and you have to press the numbers to get there, by the time you get to a person, you're even if you weren't pissed off before, now you are. Like, okay, fix this now. Been on the phone for 10 minutes pressing stupid buttons, like the opposite of what they want. And then if you think about a chatbot, with natural language recognition, if it's not recognizing what you're saying or not giving you relevant recommendations, yeah, that's just going to make you mad and be like, why am I talking to a stupid robot? Just give me a human. That said, if you look at, Microsoft has not only done this, but we've also done it with Macy's and Hewlett Packard. Those are kind of our two big, or so the Microsoft call center, one, Microsoft had tons of products. Macy's and Hewlett Packard, they have big call centers. And they implemented this. And what they really use the chatbot for is that kind of first level of questions, like, where's my package? And then it can walk you through in a natural way. Call centers are starting to get more adept with this. But then what this goes into is that human AI, socio-technical systems, like how are the two work together? And now you add sentiment analysis into that. So you can tell if people are starting to get annoyed at you. Typically what these systems will do is they'll try to answer you with a bot so they can scale this better. If you're getting annoyed, it will just automatically bring a person straight into the conversation. And usually people sitting at a call center that'll kind of bring them in. But now you have like the whole transcript. So the person shouldn't have to answer all those questions. They've got, the whole transcript, everything that you said to the bot before, first of all. Second of all, what we're seeing now too in these kind of chat, call center type scenarios is the people that work in the call center are using bots for themselves so they can ask questions on the best way to answer users' questions. So they're getting the benefit of the artificial intelligence, but they're then talking as a human to another human. So those are a few different ways. I mean, it's a really interesting question. It's an interesting scenario because it's kind of people are still used as that stopgap. And this is called interactive machine learning. This is something else that I love to talk about. But it's that how you're putting people and AI together to maximize the benefit of both, and that's really common in a call center type scenario. I know we're over time. I don't mind staying to ask questions, but I don't know if
there's maybe two last question in the chat. One
sure.
of them from Dr. Yetter, and there's another student also.
Okay, the future analyst is not a developer, but someone who takes off-the-shelf solutions, marries them with data, trains the models, and customizes them. Okay, yes, absolutely. It's funny, as someone who kind of learned how to code, in a classroom with a book, and honestly, it was hard. And I'll tell you, I don't tell many people this. I'm going to tell you guys this, just being like, I got a D in my first computer science class, a D. Now I work for Microsoft, so you can. But it was really because it was hard to learn that stuff from a book and from a teacher who kind of wasn't very good at English either. So now today, you have so many examples, so many like pre-baked solutions that are out there on the internet, so many tutorials to kind of help you get over the hump. If you have a specific problem, most of the times someone's seen that problem before. It's very rare that you're going to find something that's no one's ever solved for before. And in that case, instead of like a full-blown computer science degree, I think there's a couple things that people should focus on here if they're thinking about how am I going to utilize AI in my career. One is like just basic coding skills. If you get the basics of code and you know how to find code and kind of integrate it with your solution, because a lot of times I think that's how we see things getting built. So it's like this kind of copy paste culture and development, but hey, there's nothing wrong with that. It's like getting off the shelf parts or getting parts from somewhere else. If you're building a car, where is that transmission coming from? Where are the parts of the transmission coming from? You're not making them yourself, but these companies aren't. They're sourcing them from somewhere. So software is following that same exact trend. But if you can at least read it and understand it, that's a key. And then, you know, secondly, and this I think has been overlooked a lot in the software industry for a long time, is those human interaction skills that are really key to understanding the problem and solving the problem. I think over and over I've seen, you know, where people will look at a problem, they don't understand it from a business context, or, you know, what they beat us up at Microsoft all the time. They're like, sure, talk to developers, but really talk to the business people to make sure you're working on the right problem. So those kind of soft skills, being able to kind of work with people and understand things from a business context, from the larger picture, is really, really important to successfully implementing these things. You know, that's where I go back to, you know, all of the stuff that you learn in the technology management program about all of these aspects of business, understanding how they come together, understanding how to pitch ideas, sell ideas, understanding how to rapidly prototype and show value quickly. You know, if you have those kind of fundamental skills, you know, languages are constantly changing. You know, I started off, BASIC was my first language. I don't even know how many programming languages I can use anymore. It doesn't matter, because there's always going to be another language. There's always going to be another framework. But if you get the fundamentals and you know how to really kind of understand why you would do things, understand, be able to communicate them effectively, I think that's how you're really going to be successful. And especially, and my one last point about this is, you know, from a data science perspective, a lot of times you're not just, you know, solving, you know, oftentimes you're solving real business problems. So being able to understand that from that context is really key, I think, to be successful in this. Yeah, let me see. Anything else in here? Yeah, but Microsoft is good at chatbots because you can get a call from a real person. Exactly. You know, and that's the exactly the workflow that I was talking about. Yeah, and cool. I think that's it. I think that's all the questions, unless anyone sees anything else.
Chris, I wanted to thank you for a great presentation, and also a couple of shout outs along the way. I mean, I threw into the chat window that loved having you in class, and you got a mention in the book as well for your examples and other stuff. So as well as Dr. DeBob is mentioned in the book. And that what I hear from people is oftentimes it's helping them develop some new muscles or learn something of not becoming a developer themselves, but at least engaging with the tools and learning the language of analytics, because we're all being affected and driven by it at such a level that it's important for technologists, even if you're an engineer that's never been a coder before, to at least understand a little bit of that language and the tool set, and be able to dive into it deeper if need be, or know how to better engage and interact with sophisticated developers like you and your teams.
Yeah, I totally agree.
I think we're a little over time. Thank you so much, Chris, for a great presentation. I saw lots of questions. Thank you.
Yeah, no problem. It was fun. Thanks a lot, everybody.
Thank you.
Thank you so much.
Bye.
Thank you. Thanks.